Hello, folks. Welcome to Printavo University number 2. What's up, everybody? We're going to give just a minute or two here for folks to log in and send some notifications. But as we wait, in the chat, tell us where you're watching from. Where are you at? We'd love to know. My name's Nick. I'm one of the onboarding and sales people at Printavo. I'm actually broadcasting out from California, here in sunny Glendale, California. We got Matt and Mike here too. We'll give them a better intro in a second. But where are you guys calling in from? Ooh,
what up, Kim?
Yeah, Kim from Chicago. We got Durango, Colorado. Love to see that. Ooh, Detroit. Nice.
Mr. Richard Greaves, represent.
Dave's in Chicago too.
Mr. Eggers, yeah.
Alan, hey Alan, how's it going? Out in Kentucky. Ooh, another Colorado, Houston. Great. Well, we got some folks here. Let's dive in. Like I mentioned, my name's Nick. I'm on the sales team at Printavo. Matt and I have been doing these Printavo Universities. This is our second one. The first one, we talked a little bit about just running a shop day to day, getting sales. This one is all about screens. And Matt brought in a special guest. So, Matt, how about we intro our guest?
Yeah, absolutely. So when we're trying to figure out what we want to talk about, who we want to talk to, obviously screens is a big part. Obviously, screen printing, right? So over the years of doing this, I've made a lot of friends, talked to a lot of people. There's a lot of great guys that are out there. Some people in the chat right now that are different levels of brains that I could only aspire to be. But I was lucky enough to become friends with one of them, Mike Ramirez, who we've got on here. I met him when he was just a lowly screen guy at a shop, and watched him just take it to the next level and then the next level and the next level. So it seemed like a perfect fit to jump aboard. So without any further ado, Mike Ramirez. Woo!
That was a great intro. The best I've ever had.
Everyone's applauding right now.
For sure. I know.
They're all doing it. They're all doing it.
No, thank you so much, guys. That was great.
Yeah, Mike, thank you for joining us. It's going to be really exciting. Let's start out with an easy one. Just tell us about your current job. What's it like day-to-day testing emulsion?
Yeah, so we don't just test emulsion, but yeah, I work for Kiwo Inc. here in Houston, Texas. I work in the applications lab, and the lab kind of, it's like an umbrella. There's a lot of little functions that it performs, but one of the main ones is like the research and development that we do. So it's a lot of product development, a ton of product testing. So if there's a need or a hole in the marketplace, we try to fill that. We fill that need, we fill that hole. If it's a new product that we need to develop, our chemists will come up with a formula and sort of direct the product to fill those needs. And then what we do is we just test it in the lab. And when it's ready, it goes to market.
Yeah. What's one of those needs you mean? Like, what's a need that somebody's came and then you guys developed from a customer need like that? That sounds interesting.
Yeah, I mean, screen printing isn't just textile. So there's industrial, there's all kinds of different types. But if a printer is in the middle of a jungle in Honduras with, crazy humidity in the printing solvent, nameplates or something, they need a different type of emulsion than the guy down the street printing t-shirts in his garage. So what we do is we just try to tailor the products and get it out to them and get everything going.
Yeah, I'd love to hear it.
Yeah, I mean, in the lab also, we do a lot of other things. Like we'll do a lot of sampling for people as well. So if they want to test a product, sometimes we'll make the screens with our products and we'll send it to them. They could do their own testing in their own facilities. And if they want us to do the testing, we do that as well. We have, the capabilities to do that. And
Sure.
Of course, technical support. So if someone's having an issue with a product or they have questions, they could just call in and talk to us directly, and we can help them remotely over the phone.
Nice.
Yeah, well, I think all our viewers today are lucky that they're not printing in the jungles of Honduras. So that simplifies things a little bit. Let me ask you a question that's kind of a general question, but for, we got a bunch of different people watching. Tell us about what are different criteria that make emulsions different? And how would someone evaluate which one they should be using? What makes it the right one for one person?
Right. So everyone's going to have their own needs. You just got to qualify that and figure out what you need, what's working for you in your current emulsion, what isn't, and then we can find something that works for you. There are different types of emulsions. There's 3 main categories, like 4 if you want to be really technical. So most textile printers will use a single cure SBQ, or single cure photopolymer, I believe is what Matt likes to call them. We have diazo emulsions. So it's a straight diazo. It requires an added sensitizer to basically work. Otherwise, it's not going to do anything. It's just going to fall off the screen. We have dual cure diazo. So it's sort of like a mix of the two, sort of. It's going to have 2 sensitizing components. So you add the diazo to it, and it has an additional component in there that's going to really harden it up. And then the 4th type is a dual cure SBQ. So I hope I didn't just confuse everyone by going out of order.
No, you didn't. But I've got a question. So from one of the experts, one of the guys that does this for a living, what's your favorite?
My favorite? My go-to? Yeah. I always pick the dual cure diazo emulsions, just because for me, it's unique.
I couldn't agree more. I mean, all of them work, right? Like you said, you got to qualify what emulsion you need. But when it comes to holding the quality and getting some of the prettiest prints I've ever seen, that's my go-to type of emulsion as well. So there's not a wrong answer, but that was the right answer.
Yeah. No, yeah, that's my personal preference, just because you have a lot more latitude with that type of emulsion. You're going to have some of the best resolution, some of the best on-press durability, which means it's not going to break down when you're using different types of ink. When I was in production, we would run plastisol. We were doing textile prints, but we would do plastisol and water-based and discharge. So that kind of protects from all of those things. You don't have to switch emulsions when you're switching inks or whatever. And the resolution was great. We did a lot of half-tone printing, a lot of simulated process, and never had a problem holding my resolution.
Love it.
Yeah. I'm going to share our PowerPoint here. So when we're looking at emulsions, tell us about, does exposure time matter? Like, how should we be thinking about this? Tell us about exposure time at EOM and how you evaluate that sort of stuff.
Yeah, so one thing that Matt knows about me from the time when we worked close together is that I'm a note taker. And I like these photos here because these are directly from my notebook. I just collect as much data as I possibly can. So to answer your question, yes, EOM matters. Exposure time definitely matters. And what I would do is document all of these things, and that way I can track and follow these screens wherever they're going, whether it's through a shop or I'm shipping them to a customer. Then I can refer back to these screens. I can know exactly how I coded them, exactly what the EOM was, exactly how long I exposed them for, and then I can I can supplement this data with, yes, this worked, or no, this didn't work. So what you're seeing here is some of my notes. Yeah, that's it.
So those years that I got to work closely with Mike, I'd go into the shop and I was the sales guy that would help out with the equipment or supplies, and then I would help troubleshoot. And pretty quickly, I hit a point where like I was going in to help troubleshoot with Mike, and all of a sudden he's like 3 steps above me and like what he's talking about and doing. I was like, oh my God, what? I was like, it's like the Rain Man of screens. He's just at a different level. So the awesome part was like going in and like seeing his incredible note taking helped me also better myself and want to catch up with what he was doing. So I go in there and like pick his brain, and he'd bust out these notebooks just with these amazing scribbles of like everything going on with all the screens that were happening. So he took it seriously from an early stage, which I think is why his career's progressed so much. And he's literally the guy at the lab helping make things go. So yeah, these notes are key. And I think the point there on that slide is that good data equals good screens. And we're going to dive a lot more into that as we go, but it's really imperative to take good notes and actually be able to track this kind of stuff.
Yeah.
Yeah. Tell us what this means. What is, I'm sure everybody's heard EOM, but tell us what we're actually looking at and thinking about when we're thinking about EOM.
Right. So EOM stands for emulsion-over-mesh. You can see it there in the slide. And it's basically, it's your stencil buildup, how thick or how thin your stencil is on your mesh. So when we talk about proper EOM, there's certain standards that are out there that we kind of follow. And one would be, if you're running certain types of inks, UV inks with high mesh and things like that, you're going to want to have like about 10% EOM. What that basically means is 10% of your total mesh thickness. And so what we're talking about here requires a tool to measure this. So you have a thickness gauge and you're able to measure your mesh thickness, and then you code it and you measure it again, and you want about 10% of that thickness to be on top of that mesh.
And that makes a big difference on the print quality, right, Mike?
Absolutely. It could make or break a print. I mean, among other things, but that's one of the main variables, definitely.
Yeah, so it can be too thin of an EOM, or it can be way too thick of an EOM, depending on what you're trying to achieve. You can also have EOM on the wrong side of the mesh, right? You could build up that stencil on the opposite side, and all of a sudden now you got little divots that your squeegee is going to start getting stuck up in as it starts to go. Right.
Yeah, you want to make sure your stencil buildup is on the correct side of the screen, which is the print side of the screen, the side that is going to touch the substrate. That's where you want your stencil buildup. And yeah, you're absolutely right. I mean, if you coat too thin, you're going to get sawtooth and stair stepping and all these things that you don't want to see in lines in your print. And if you go too thick, your ink deposit is going to be really pretty horrible. It's going to be pretty wonky looking.
And so your dots are going to gain massively, right? If you're trying to once you start getting into halftone, it's going to cause all kinds of problems. So you really want to dial that in. There's a sweet spot for each mesh, because it's dependent on your mesh thickness. So every mesh count is going to be slightly different.
Well, how about this screen? How's this one?
I think everybody here watching has seen that screen, and if you haven't, bless your soul, you're one in a million. I mean, that to me that reminds the first 20 screens I ever coded in my life. I either spilled emulsion all over my basement carpet, just made a giant mess, or once I was like, oh, I think I finally got it. You come back a half hour later and the dreaded drips are just all over. It's like screen chicken pox. You just know that thing it's not going to survive. That's going to always tell you a couple things. It's way too thick of a coating, or you are coating a screen too heavily and you are in that rainforest he was talking about, and it's just absorbing all that moisture then. Yeah, Mike, tell me about this picture. Where'd this come from?
Yeah, I don't know. This is actually a found picture that I found, but it basically is a perfect representation, like you said, of every screen I coded in college. That just looked horrible. I wish I could say I was always pretty good at coding screens, but that's not the case. But yeah, this is clearly coated way too thick. So you can't even tell if they use a scoop coater or not, which you want to use a scoop coater. If you're coating by hand, use a scoop coater. It's uneven. You see the bubbling, the pooling, like you said. It's way too thick. You're not going to get any sort of use out of this screen. You have to reclaim it and start over again.
Well, in contrast, here's a screen. This looks like what you want, right?
Yes. This is a good screen. This is much different. As you can see, it's not, it's not 3D, right? It's not sticking off of the mesh too high. You got a nice uniform coat. It's been clearly coated with a scoop coater. I have no problems with that, mainly because I did that.
Now, we talked about how good data is good screens. And here we have a picture of a whiteboard where you're tracking that data. Can you break this whiteboard down for us? Tell us how people could start experimenting in their shop by recording data like this?
Yeah, so this photo is actually I took in our screen room when I was working in production in a textile shop. And what it was basically on the left column there, you see the mesh count. So there was a lot of different mesh counts. And like I said, every mesh count is going to need certain things. They're not all going to be coded the same way. Not every mesh count is going to be coded the same way. They're definitely not going to be exposed the same way. So what I would do is, for our production team, we would document these things. We would test it, and then we'd write it on this whiteboard for everyone to see. So no matter who is out there coating screens, or in this case, exposing screens, they would do it the same way every time. So it creates redundancy. So basically what this is all the mesh counts. I think the top row had, different emulsions or something like that, but all those other numbers you see are the EOMs that were recorded and the exposure times that those need to be exposed at.
Got it. So your EOM on those, you've got a pretty big gamut there, right? You've got, I see as low as 13% and as high as 43%. So you might even want a different EOM for different screen meshes and different needs, right?
Right, absolutely. So like I said, EOM is going to be a certain percentage of your mesh thickness. So the finer the mesh, the thinner it's going to be, the less emulsion you're going to put on there. Some of the EOM percentages on this are kind of wonky. I'm not sure where those all came from, but you're right. The higher meshes are typically going to have, you want 10, maybe 15%, not too much higher than that. If you're running, really coarse artwork, big blocky letters, the neighborhood school, the Printavo shirt, you're going to want to use a lower mesh count. It's going to have a higher EOM percentage. Normally around 20 is where you want.
Partially just because that actual mesh, the coarser mesh, is also a larger mesh. So a percentage of a thicker mesh is still a higher percentage, correct? So that's why it's going to still be where you want it to be. Plus you want to stand up and actually get a good lay down, but you have to also cover all those knuckles of mesh. So it's going to take a little bit thicker of a stencil to do so, right?
Right, exactly.
Cool.
Now, once you have this calculated, is that? You got your whiteboard, you write it up there, you're good to go. You can just leave it as is.
I wish that was the case, but it's not.
You can't set it, forget it, Mike. It's not like you just dial it in once and you're good.
No, it's constant dialing in. Depending on where you live, sometimes you got to do a little more. But if you're running the same emulsion, different environmental sort of changes are going to affect your coating and your exposure. So in this case, we did this like every quarter of the year because the weather was changing in Chicago so much. So in the winter, our exposures were a little different than they were in summer when it was more humid. Things were taking longer to dry and so forth. So once you're able to sort of calibrate your screens like this and have this data, you're going to want to continually check that. You don't want to just leave it forever. And it's just, you want to stay current. You want to stay up to date with it.
Yeah, and you mentioned humidity, which is why we have a picture of a hygrometer in here.
Yeah.
So tell us, why should people have these in their shop, and how many should they have? Should they just have one in the dark room, or what's up with these things?
Yeah, this is a great, easy, cheap tool to have, just so that you have some sort of record of what your environment in your shop is like. This one, I think, was in a screen room. That's definitely important. You don't want it too dry. You don't want it too humid. We could talk about that as well, but you definitely want one of these in the screen room, and having one out on press is not a bad idea either. And this way,
so with these, I find that it's really, like I said, on press is great because you're going to be able to actually see, like, my ink's acting differently. I'm running water based. What's the humidity level looking like? And you can tell, like, oh, it's a low humidity. I'm in the middle of a Chicago winter, right? I'm having a hard time. You can also start to figure that out if you look in the morning, like, I got a high humidity morning. Start looking at the forecast. Like, it's going to dry up later today. You can actually get ahead of that by scheduling that water base in the morning when you've got that higher humidity. So you actually work with what you're given climate-wise to make it best. But like you said, in a screen room, super imperative. This little tool, I want to say, is like 10, 15 bucks. You can get on Amazon, wherever, and it's going to be clutch. If you want to actually you want to coat a rack of screens, right? Everyone's always complaining about how long screens take. Well, they coat 20 screens and they just put them in the room, and they're like, this emulsion's taking 3, 4, 5, 6 hours to dry. It's like, oh, well, what's the temperature? I don't know, 70. What's the humidity? I don't know. What's the humidity outside? Well, that doesn't tell me anything, right? So making sure that you've got humidity where it's controllable. You don't want to go necessarily bone dry, because you might have an issue if you are a shop lucky enough to have like a computer screen. You might have a hard time with that ink actually sticking to the surface tension after if it's too dry. But I don't know about you, Mike, but I always love to say, like, hey, you should try to have a dry box. If you can, you can build one too, right? A dry box. Maybe you force that to be like 35% humidity and like 90 to 100 degrees. You throw a rack of screens in there. If they're coated correctly and they go in there, they should be able to be dry in like 30 minutes, a whole rack, right? And then you take them out. We want to store them usually in about what we're looking at right here, right? Like 45% humidity and around 90. Would you agree with that, Mike?
Yeah, I mean, when you're storing screens, you want it a little cooler, depending on how long they're going to sit there on the shelf. If you're going to use them right away, it's not as imperative. But like if it's going to sit there for 2 weeks, you want to keep it around room temp if possible. And that's for storing after storing a dried screen. But yeah, you're right about the dry box. It's the fastest way to get your screens dry, and it also separates them because they're releasing moisture. So you don't want all that moisture being released while it's drying, sitting right next to your screens that you're storing to be used later.
Now, I got a question for you too. How long would you recommend you have between screen coated and dried to actually using that screen?
Well, that kind of depends. It depends on how safe your room is that you're keeping it. I mean, if you have light leaking in there and you have some light bleed, they're probably not going to last as long. If you're using different types of emulsions, like we talked about earlier, if you're using a very sensitive single cure SPQ that exposes very fast, it's not going to last very long at all. If you're using a diazo dual cure, you can sit there a little bit longer, but you don't want a screen sitting too long. The exact time is kind of hard to say, but I would say if it's a diazo dual cure, maybe a week at most. You can probably stretch it, but temperature and humidity also play a factor in that as well. It's not just, it's always going to be a 2-week time period. If it's humid in there, it's going to cause some issues. If it's too dry in there, it can cause some issues as well.
And that constant back and forth of it swelling, right? Swelling and drying and swelling and drying. Is that going to also make it more unstable?
As long as you're not exposing it when it's moist, then you should be okay. You want to expose it as dry as possible.
Good to know. Awesome.
Yeah.
I got an easy question that I think is going to have a hard answer. How do you know if you made a good screen?
That's a great question. I wish more people would ask that. This picture, I love this picture. This is Dave Dennings in our applications lab. Dave Dennings is Kiwo's product manager. He's responsible for all of my screen printing education. But this is him demonstrating how to check like a screen after you've coated it. And what he's doing is he's looking for the gloss. So you can see the shine of the light there on that emulsion. That's what you're looking for. So to get back to your question, how do you know a screen is good? It's kind of a subjective thing. Everyone's going to have a slightly different need. So as long as that screen is filling your needs, who's to say it's bad, right? But what's a good screen to Matt may not be a good screen for me. So I have my own personal sort of like checklist that I made to make sure that my screens are processed the same way and processed in a way that I feel is good. But I also have a lot of tools to measure these things. So what he's showing on this photo is a perfect way and a very simple way to make sure that your screens are coated thoroughly. Because when you coat a screen too fast, or you're coating it with maybe too sharp of a trough, and you're just coating it maybe one on one side and one on the other, you're not actually encapsulating the mesh. You want that emulsion to fully encapsulate the mesh, and you want it to be on both sides of it. And what you do is you coat the screen on the substrate side, and you're basically going to coat it as many times as you need for it to get glossy, like you see in that photo. So most of the time you can get away with 2, some finer meshes, maybe 3, but not many textiles are going to be printing with like a 460 mesh. So as soon as you get that glossy side, you've pushed all that emulsion to the squeegee side, and you can flip that over and you can coat that squeegee side just one more time with your scoop coater. It's a good starting point. That's a very good point to start your testing.
Yeah, that's the Dennings way, which I've used that line, the Dennings way, for years now, since seeing Dave Dennings in person do this. And shout out to Dennings, who is in the chat here. We've got a handful of brilliant minds in here, Greaves, Dennings, so appreciate you guys being there. So yeah, to what Mike's saying, how do you know your screen is good? I think Mike would agree, is a couple steps to that, right? That's just one phase of it. You got to make sure the screen's good before you coat it too. So you have to make sure it's good across multiple areas. So I usually kind of break this down to a pre-coated, a post-coated, and a post-exposed to make sure that the screens are good, because those variables can change across the board, right? So I always like to first make sure that the screen is worth my time coating it, right? I don't want to spend time, energy, and money, because I'm getting paid to coat the screens and I'm putting on emulsion onto the screen, right? So I want to make sure that it qualifies for my attention first before I actually coat that screen. So making sure it's properly degreased, properly reclaimed, making sure it's a proper screen that is worthy of my time and my emulsion to marry to it, right? To actually get coated then. And then, of course, making sure that after it's coated, it still looks good. You're not going to want one that has dust everywhere or issues all over it, that then you're like, yeah, we go ahead and just put the film on that and expose that. It's going to work out okay. No, it's not. We all know that, right? And then again, make sure after we expose it's also good. Making sure you don't have any particles that were on the glass when you're exposing it that cause an issue, right? Or making sure that after you develop it, you didn't over blast out your halftones. So really qualifying your screen at multiple steps is going to be really vital to help making sure that that screen is good. What do you think, Mike?
Yeah, absolutely. No, I mean, you nailed it. Yeah, like I said, I have a checklist that it was more of a mental checklist, but I wrote it down. Yeah, it starts in reclaim. It really does. I mean, if you don't reclaim your screen well, you're not going to get a good coat. You're not going to get a good image. You're not going to get a good print. You're not going to have a good end product. So you want to make sure that, when you reclaim your screen, that you're getting all the debris off of it. You don't want any emulsion particles on your mesh. You don't want to make sure you have any chemical residue. You need to degrease the mesh. Make sure you degrease it. Nice flood rinse. Make sure we get everything off of there. And once you have a perfectly clean mesh, then you want to dry it. You want to make sure that it's completely dry, 100% water-free. And you want to do that like you said, in an area that's contaminant-free. You don't want any dust on there. You don't want any cardboard pieces, whatever's in the shop. You don't want that to touch a wet screen because it's a magnet. It's all going to suck onto it. When you coat it, you're going to be coating over garbage and debris, and it's going to ruin your screen, like you said. And you got to start all over.
Now,
yeah, I dig it.
We've been talking a lot about mesh. We got this mesh cheat sheet. Tell us about how EOM and this mesh cheat sheet, we were talking about EOM earlier. How do they relate?
Yeah, absolutely. So this mesh cheat sheet, and I'm pretty sure that we can actually add a link. This is a free download that we'll put out there too. This is going to be a good way for folks just to kind of figure out like what mesh should I use, because talking about those variables, EOM's one. There you go. There's the link right there. EOM's one big variable, so that emulsion-over-mesh is really going to help define what your laydown looks like. But before that, you still need to make sure you're choosing the right mesh for the job, right? So a lot of times, I've been lucky enough through my career to be able to go into hundreds of shops, and a lot of these shops I'd go into, I'd walk in and take a look what they're doing, and they're printing things just on a whim. Like, oh, why'd you choose a 110? Oh, it's what we had. Okay, what's your LPI on that? Oh, what do you mean? So it's really imperative to understand that all these things have a reason and why they want to be chosen. So you're gonna want to make sure you understand when to choose what mesh count. Now on this, we've got a little halftone rule of thumb, and this rule of thumb can be broken and oftentimes is. So by no means is it the law, just a rule, right? So traditionally you want to look at your art, right? So a good screen from reclaim before you coat it is really important. Also, having good outputs, so good film, or if you're on a CTS, making sure that you've got good outputs and understanding what you're outputting and why. So things like LPI or DPI, lines per inch, dots per inch. Us on the art side may understand that a little better than some other folks. That's going to let you know that in a 1 square inch area, how many lines do you have? How many dots do you have? How much data are you trying to force through? So that kind of coincides with your mesh. Every mesh, the mesh itself, if it's a 110 mesh, that's saying that in 1 square inch, there's 110 little knuckles or openings, right? So you have to know, based off of the output that you have, what the LPI is, how that's going to actually marry correctly to your mesh, and where will you actually be able to hold the data you're trying to get across onto the substrate. So it can be a little cumbersome and it might throw people off. So this little cheat sheet is kind of a way to help explain what the mesh counts are, where they're ideally used, and then a little bit there on how to help choose what mesh count you should have. So the rule of thumb is the 1/5 rule. I find that it's really kind of a 1/4 rule, but it was called the 1/5 rule. And you take your LPI and you multiply that by 4 or 5, and that's usually going to give you a pretty good starting point. Now, if you're putting something like this, maybe you'll output it at 35, 45 LPI, but you're not actually holding that small data. So you don't really need to worry about too much then. But once you start getting to fine lines and halftones, it's really imperative to understand how those things work together and be able to pick the right mesh for the job. And then, of course, you need to pay attention to that emulsion over mesh ratio, right? So making sure that you're also coding that screen correctly. If you're going to do something that's at a 55, 65 LPI and you're trying to run a 305 mesh and you're going to code it with a 70% EOM, it's going to look muddy, right? If you're going to even do it at 50%, it's going to look muddy. You need to make sure that you're actually taking the right arc to the right mesh and then building up the correct deposit of emulsion to translate that to the garment the best.
Now, speaking of the correct deposit, tell us about this diagram. Is this what we want?
Yeah, and this goes kind of along with what Matt was saying, and this is sort of to illustrate the art to mesh relationship, right? So there's different mesh counts, like you mentioned 110. So when you're printing with a 110 mesh, you're most likely not going to be printing at 65 LPI. And why? Because you're not going to be able to hold those dots. Those dots are going to be very small. Your mesh is going to be very big. So you don't have enough surface area for that emulsion, those dots, to hold on to. So they're going to fall off. You're going to lose them. You're just going to be printing ink. You're not going to have any stencil there to block anything. So what this is saying is, 2 threads, 2 mesh openings for a halftone dot is what you want. That's a good place to start. And it's a little difficult to figure out a good way to do it. You're just kind of, if you're using film, maybe just take the piece of film that you want to print and put it on an uncoated screen. That's the easiest way to see your smallest dot and if it's printable. Because if you have too many mesh, you don't have enough mesh openings, you're going to be losing. If you're printing with too coarse of a mesh, that thread could be blocking a dot that you need, a highlight dot. So you want enough mesh openings there for the ink to pass through to get you the resolution of that dot. Otherwise, you're going to be losing it. Does that make sense?
It does. Here we got an actual microscopic image of a screen. It's saying the same thing, but tell us more about the dots on this image and how here's what we want.
Yeah. So this is just an actual photo of that illustration that we just saw. So what you can see is these dots, a lot of them are being cut off by threads. And that's because these dots are too fine for this mesh count. So if you look, there's a dot, it's like the 4th one over, the 2nd one down. It's almost completely covered by the knuckles of that mesh. That dot will not print. That will not make it to your substrate. So what you're going to get is a pattern. And as that repeats, you can get problems with moire. Your tonal values are not going to print correctly. Your colors are going to be all over the place if you're printing, sim process or 4-color process. So what you want is these dots to have enough real estate to hold and print well. And you can see some of these are just one mesh opening. And Matt, as you know, some of the presses and some of the ink types that we use, we're not even going to be able to print that dot, even if it's there on screen.
Sure.
That goes to the LPI against that ratio that we were just talking about, right? So in that example, the LPI doesn't actually match up to the right mesh count that you need to hold the dots you're trying to achieve. So it's one thing just to have some high meshes and then be able to actually click print and generate halftones. It's another thing to actually be able to marry that to the screen and actually get that onto the substrate. And so if you don't know where to go or how to marry those up, that cheat sheet's going to be pretty helpful. What up, Dylan, in the chats there? Glad you could join us. And podcaster to podcaster, it's good to have you, brother.
Yeah, thank you so much for the folks joining in. The question I'm having is, how do you start getting better at it? How do you level up your game? Tell us about exposure calculations and how you actually do something like an exposure check.
Yeah, I mean, this is so important, and there's so many variables. There's so many things that go into screen making, and we'll talk about. But exposure calculation is definitely a must. Now, I'll say before we get into this that if you are coding these by hand and you have 5 different people in the shop and they're all coded differently, this exposure calculator is not going to be as effective, because Matt's going to code screens differently than I am, and Nick's going to code them differently than Matt. So you want to make sure, and that picture from earlier, that production picture of the whiteboard with all the documented times, and have some standard operating procedures in your shop that if you're printing or if you're coding a 110 mesh, it's always coded the same way. That way you have some sort of redundancy in your screens as they're coming through and being processed. So does that make sense?
Yeah, no, I mean, absolutely. I've seen that too, running shops, that somebody calls off sick, right? And you're like, okay, well, I've got a backup that I've cross-trained on how to code screens. And they're doing their best job. They're doing a good job coding screens. But as soon as I hit press later that day of the screens that they coded and then imaged that morning, I'm going to press and going, what changed? This is a reprint we did last week, and it was a no-brainer. It was easy. Why is this not right? And the poor guy coding screens is doing the best that he can, but he's going to have a different speed. He's going to have a different pressure. He's going to do, well, I did a 2/1. Well, are you mechanical? How do you know your 2/1 matches the last guy's 2/1, right? So if you're lucky enough to have an automatic coder, that's a variable that you're actually able to control. And once you can control these variables, you're going to be a lot better to actually be able to test and go back in the process and see what's happening and why. But just like Mike said, if you're coding by hand, it's definitely ideal to really get one person that you kind of default to at most times. They're going to find they're going to have a natural rhythm of things, and they're more likely to hold that as a semi-controlled variable where you can start doing these kind of exposure calculations and actually have some sort of real good data to pull out of it. If you've got 8 people coding, these are going to be all over the map. They're not really going to help serve you too well here, right? Right. But Mike, tell us what we're looking at here a little bit, and how that kind of works in an abridged version, if you can.
Yeah, so this is just an illustration of an exposure calculator. The green that you see, that would be the coded emulsion that's been exposed. And then the black is the film. That basically just represents the actual hard copy of this film that I have here. So what we do is we have this film here. I don't know if you could see this. It's this is our exposure calculator. So if you could see that there's a film here in front of it, this is a filter. It's a neutral density filter here. So you can see the repeating images, but this one's dark, this one's a little lighter, and so on, until you get to the last one, which doesn't have any filter. And what that's going to allow is for 10 different exposures. If you look at the illustration again, you're going to get 10 different exposures on one screen, okay, with the repeating image. And the images are exactly the same. So this is how we check our resolution. That's why that's repeating that way. And as you can see, the color change. So the lighter color there is the least exposed out of all of them. So when you're underexposed, you're going to have a lighter chalky color. As the screen reacts to the UV, as it starts to actually cure, it gets darker and darker and darker until it reaches a point where it basically doesn't change color at all. And we call that no color change. So we use the no color change method to dial in our exposure time. So if you look, we have 0.1, 0.2, 0.3, all the way to 0.5, you see a subtle tonal change. So you get to 0.6 and on, there's no more change in color. So we know for a good starting point that 0.6, whatever that is going to be where we're going to start our exposure. And I went ahead and put it at the top. So if I expose the screen for 60 seconds, 0.6 is going to be 36 seconds. It simulates, it simulates like 60% of that.
Got it. So you do this, then you'd go ahead and look and say, okay, so the no color change, right, is starting at 0.6. So I'd know that it's 60% of the time that I put it through, but we also want to look at the other variables in that, right? So then we want to start looking at, when we rinse it out, where are we actually holding the most detail, but we're only really caring about that no color change area, right? So that 0.6 all the way up is what we're looking for. And then we'd see, okay, based off of all that data, where are we holding the best points? We might find that it's the 0.6, the 0.7, or even like a 0.65, right? So it might land between the 0.6 and the 0.7. And then that would be where we start our next exposure, right?
Right. So, I mean, that's why I said this is a starting point. Because depending on what you need and what you're printing, you may want to extend that time a little bit, or you might want to, lower that time a little bit. You might want to be in the 0.4 range. If you're printing plastisol inks and you're only doing 10 shirts, but you have really fine halftone that you've been having trouble, gaining or resolving in development, then maybe underexpose it a little bit. But if you're running long runs with Discharge and you're just printing Printavo text over your shirt, then go ahead and move it up. Then you're going to have a more durable stencil. It's going to be more resistant to your inks, and you don't have to worry about closing in any sort of fine halftone.
And you've done 10 exposures on one screen, right? So you're getting so much more data out of having to, you're not wasting screens. You can really get all of this out on one, maybe two screens to actually hammer in what that exposure calculation is. But that's going to be per mesh, right? It's not going to be across the board. That's per actual mesh count, right?
Exactly. Every mesh is going to expose differently because it's going to have a different amount of emulsion on it. It's going to have a different EOM. And then not to mention, mesh colors, you got your white mesh, your yellow mesh, some of those like clear transparent meshes that I've seen. This is just the starting point. This doesn't mean that, okay, expose this at seconds, because you might not need it there. You can use that 36 seconds and dial this in even more. You can dive in even further with another screen using a shorter time.
Okay.
Love it.
So when we're looking at these two images, which one is exposed correctly and which one isn't?
Okay, yeah, I love these. This has to do with EOM. So the image there on the left looks a lot different than the image on the right. The image on the left is a very thin coating. That's what it looks like when you coat your screens too thin, when your EOM is too low. And you can see that there's no stencil wall. There's no stencil at all almost. It's just barely covering the mesh. So your resolution is going to suffer horribly because you're going to print that line. It's not going to look like that. You're going to get really bad sawtooth. Your stencil is most likely going to break down because there's not enough emulsion there. If you're printing, a harsher water-based ink or Discharge or something.
You're also not going to encapsulate the fibers of the shirt. If you're printing on a fiber shirt and that's the stencil you're working with, you're going to have such a thin deposit of ink. If you're on a manual press, you're going to print that white before it starts to look anywhere near good. So the amount of the manpower and the time that goes into it, you're going to be killing yourself. Even on an auto, for that to look good, it's still going to be a print. And then you're still going to have sawtoothing and edge definition that's going to be garbage. Where the other one, like I'm sure Mike's going to go over, you can see an actual wall that it's built, right? It's actually got an area to define a line and an edge, and also an area to hold ink when you flood that screen to then drop that nice deposit to shear off.
Exactly, and you hit it. That's exactly it. You can see the clearly defined line. It's bridging over the mesh perfectly. You have a nice straight stencil wall. And it's completely encapsulated the mesh, which means your ink deposit is going to be right where it needs to be.
I see. Okay, I'm starting to get this. I'm wondering, does anybody listening have questions for Matt and Mike? Start chatting up, put your questions in the chat. But I'm starting to see how you can make some really effective changes in your shop if you're keeping track of the data and you're using that test that Mike just told us about. Let me turn off the PowerPoint here. We don't got any more slides. I have a more personnel question. Not necessarily, it's about screens, no doubt, but it sounds like our reclaim person is a really important role to getting your screen game up. So tell us what makes a good reclaim person, and how do you know who to hire for this? And then, of course, folks watching, just like Cole did, drop your questions in, and after this one, we're gonna get to them. But how do you pick your reclaim guy? How do you know who's a good fit for that role?
Yeah, I mean, you want someone who can handle the job, because we know it's the dirtiest, it's the smelliest job. It's not a glamorous one, that's for sure, but they need to be someone who can think analytically at times, because they're going to have to work very closely with the screen room to let them know if something's not going right with the screens. That's going to follow into the screen room. They're going to have to make adjustments. You want someone who's kind of not scientific, but someone who I don't know, man. How would you explain this?
I mean, I think kind of scientific, honestly. I mean, I don't want to like throw you under the bus, Mike, but you're a little bit of a nerd in everything you do, right? In your guitar playing and everything. Like, you care about the variables. You care about trying to really focus in on what makes what you're doing happen, and why does it matter? It's why you're great at guitar. It's why you're great at screens, because you actually care. So in my time running shops or working with shops, I always found that the people that were willing to care about what they were doing and why they were doing it were the ones that made the best screen techs. Now, that might go from starting them off and having them reclaim. If you just give them a big room full of dirty screens and you never let them finish the screens, like if that room is constantly just being bombarded and you're not talking about what they're doing or why they're doing it, they're going to come in, they're going to show up, they're going to do the job as they understand it, and they're going to leave feeling like they never got anywhere, because that big stack of screens behind them never got any smaller. They did 100 and you put 100 back in that room, right? So first of all, make sure you have goals set for that person. Hey, if you can knock out 200 screens a day, that's amazing, and I'm going to be so happy. Maybe if you're doing a manual shop and you can do 50 screens a day and you get other tasks, that's great. Set standards of what you're expecting out of them, and then help them achieve that. And then ask questions. I always saw Mike going in and talking to the guy that was reclaiming, and he asked him questions like his answer mattered, because it did. He'd go in there and ask him like, hey, are these reclaiming harder? Hey, those jobs that had the sim process for the band we were working with, did those screens come out any different? Did you notice something? Did you have to spend more time on them? And just those little questions, the guy was like, I did notice something. Why was it different? And then Mike could start imparting his knowledge while he's gaining data points back from his reclaimer. So that sharing of knowledge helped that person actually care about what he was doing and realize what was happening. And then if he had a screen go through that wasn't right, and Mike came over and was like, hey, I coded the screen, it looks like hot trash. I think here's why. And let's talk about why. Let's explain why what you did affected me. But we can also talk about why what I did affected you based on what you're having to do with reclaim. It's all a circle, right? So really controlling those situations and helping them learn about what they're doing and why they're doing it. Now, you're not going to be able to pay the screen guy as much as maybe you're paying the guy that is running the auto at a 700 per hour rate, right? But value that person in more ways than just financial, right? You can value their input. You can let them know, like, hey, you're showing a lot of promise in this area. I know that reclaim is not necessarily the best, but it's going to be helpful for you, and you're able to learn with that. Did we lose Mike? We might have lost Mike.
I'm here.
Okay.
Can you hear me? No, we're good.
Yeah. But that's really going to be huge to actually foster those people, make them feel important and like they're going to grow with the shop. Because then you get somebody like Mike, right, who started off in a screen room, did some reclaiming himself, and then kept growing, right? Ended up being one of the best screen techs I've ever had the pleasure of getting to know. And then now he gets to work at the actual emulsion manufacturer doing this testing, whole other level, right? So it's really important to really care about those people. And maybe you have somebody in your shop that you can't find the right fit, but you notice that they are really, can you guys hear me?
Yeah, we got you.
You're lost. Sorry, my internet's crapping out, guys. Sorry. But yeah, take care of those people and foster those relationships and teach people. Let them get excited about what they're doing. Don't make them do the same thing day in and day out without knowing why they're there.
Yeah, I mean, you made some great points. I mean, education was always something I was really fond of, I guess. You know, I wanted them to know, and this isn't just the reclaim department. This is anyone else helping with screen room printers if they want. You know, why are you doing these things? Why do we have SOPs in place? Why are these things important? And ultimately, like letting everyone understand that when these things go smoothly and things are done in a certain way, it makes the shop run better. It makes everything easier for everyone. And that goes with the question, Nick, that you asked earlier, which was, how do I level up? How do making better screens help me? Like, what is the benefit even? Well, I mean, if you're making good screens from the beginning, those screens are going to move smooth and they're going to move faster through your shop, and you don't have to worry about reshooting screens because you're not holding resolution. You know that you've done the coding test. You know you've done the exposure test. You know you're going to hold the resolution that you need. You know it's going to be durable on press, and you don't have to keep stopping the press to tape up pinholes or to tape up cracks or to change out screens completely if it breaks down. And you know it's going to reclaim the way it should. It's going to be easy to reclaim. So like Matt said, I mean, communication is key. Someone that can communicate well, that can understand why they're doing something, even if it's, you know, mundane or repetitive for a while. And yeah, I mean, a lot of times I would have those guys move into the screen room because I would be constantly talking to them about screens. Once they got to back end, I would want them in the front.
Yeah, that's a great way to think about it. I talk to a lot of shops, and I don't know if everybody's thinking about it that way. A lot of folks think that the reclaim person is somebody who could just be a part-timer, doesn't really matter, but that's a different way to think about it, and that makes a lot of sense. We have a really cool question from Cole. Let's read that one out. Cole asked, what kind of EOM would you want for discharge? Low or high?
Great question. I'll let you take that one, Mike.
Well, discharge prints, you're probably going to be using a lower mesh count. So your EOM is going to be pretty much based on the mesh count that you're using. So I would say, for me, probably around 15 to 20% if you're using a 110 or a 150. I mean, if you're printing discharge, you're most likely not going up to a 225. Would you agree?
Yes, it depends on what kind of discharge. If we're doing clear discharge on our base, I may actually go that high. Okay. If I'm doing anything with acrylic, oftentimes what I like is about a 10% EOM. It really is going to depend on what I'm trying to do. If I'm trying to do this in like a discharge white, yeah, I'm going to build it up a little more. But I'm trying to get into a nice, soft, high quality sim process job. I do find that a slightly lower EOM, so around like the 10 to 12%, actually helps me from drying up as much. I've got less surface area on that wall that I've built that I'm able to not have cling up of ink drying up along those edges, which oftentimes causes it to choke, right? So we talk about dot gain with screens. We often get dot loss when we're dealing with a lot of water-based discharge because it starts to kind of cling up around those edges. So there's a lot of back and forth. You might find different answers that work for you, but I've seen a lot of really good results by having your discharge or your water-based in general really try to be closer to that 10 to 12 range. 15 is great too, but it will help really make sure you've got a good deposit, you're holding good detail, but you're not allowing just a thick stencil where that water base could actually dry up and cause more problems.
That's a good point.
I got another personnel question, but remember, folks in the chat, ask questions. What do you need to know? What do you need to know to level up your game? Just chat it to us right now. But here's a question. I'm a salesperson. How do we tell our salespeople in the shop enough information so they're not underquoting jobs, but not bog them down with too much information so that it's killing deals? How do you get that sweet spot for your salespeople?
Yeah, I mean, I'll let Mike take this in a second too. I'm sure he's got some good opinions, but educate, right? It's one thing. A salesperson is really going to be a good relationship builder. That's what they're for, right? They're to go kind of talk about what you can offer them, help people out, and build relationships. They might not necessarily be the most technical or be like screen savvy with this, but it doesn't mean they're not capable of learning those things. I would never expect a salesperson for a print shop to ever have Mike's brain. It wouldn't make sense, right? Mike's in the position he's at for that. You want a salesperson who's good at sales and talking. I'm sure Mike is, but you want someone that specializes in that. So educate them, empower them, give them tools, bring them in for a lunch and learn, right? Bring them into the office and take them around the presses, show them what you're doing and why you're doing it, and let them start understanding the variables. But more importantly, give them the tools to do this. So maybe give them some samples, give them a sample book, give them shirts that show what we can do and how we can do it. I remember the shop that Mike was at for a long time, phenomenal shop here in Chicago. They had this crazy shirt. Mike, you probably know more about this. I'm assuming this shirt, had they actually sold it, would have been like an $85 shirt at like insane. This shirt was covered in different prints, but that one shirt had all the prints they could do, the sizing they could do. It had puff, it had process, it had sim process, it had metallic, it had everything all over the place. It was crazy. It didn't look good to wear. You wouldn't want to wear it, right? But they could give that one shirt to a top-notch client, and they could say, here's what we can do. It's all on that shirt. Figure out where you want it, and let's go. You could do things like that. Test. When you're testing out new ink samples, go ahead and print some extras. Put it on a rack. Give it to your salesperson. When you're ordering shirts, blanks, it's a cool job, order extras for a couple of reasons. One, if you misprint, you can use the extras to fulfill the order, and you're getting a better user experience for your customer, right? Fulfill the full order. And if you don't misprint, now you got, okay, well, I got 5 extras. I guess I shouldn't print them. No, you should. If that was a cool print, print those extras. Put one on your rack, put one in like a sample box, and then give others to future customers that are asking questions like, hey, what's a print like that look? Here you go. Or you can mail it to them. We're in COVID right now, so maybe you have to mail it to them. Or you can just make sure that you got a good salesperson that has a trunk full of samples, and they can be like, can we do this? What's it look like? They can start to see, and it's tactile. They can feel it. They can see it. They can stretch it, right? You got a smelly ink. You can smell it, whatever you want to do. So have those samples and have them ready. What do you think, Cole? I'm sorry, Cole. What do you think, Mike? I'm reading Cole's comment. What do you think, Mike?
Yeah, no, you're right. Visuals. I'm all about that. Samples. Yeah, that shirt that you're referring to, that was a fun one to make. It was like 50 screens that we had to make for one. We only had time to make one. But yeah, if you have visual samples for your sales staff so they know the types of inks that you offer, the positions, that was an important thing of that shirt was it showed what a center chest, where it's going to be, how big it is, the capabilities. You don't want to say, oh yeah, we could print all over the shirt when you only have 20 screens, because it's just impossible. You want them to be informed of the capabilities of what you can do as well, and not only like the special effects aspects of it, but what you can and cannot do.
Yeah, absolutely. I see a question that Roberto is asking about different benefits for mesh diameter. So we oftentimes will talk about 230, 160. That's only one of the numbers that defines a screen. There's a couple numbers that define a screen, right? Oftentimes you'll have a second number, like in this question, a 230.40 versus a 230.48. Now that second number is going to reference the actual diameter of that mesh, right? So if you've got a mesh and it's all clunged up, what is the diameter of that actual thread, right? So a 248 or the 230/48 might be like a thicker diameter versus the 40 is a thinner diameter, right? So having a thinner diameter will actually allow for a larger opening, right? So take my thumb times 4, the open space is a little smaller than my pinky times 4, much bigger area. Now, what that's going to do is going to allow for a better flow. I'm personally a huge fan and proponent to have like 130 mesh. That's a thin thread mesh. I'll use that over a 110 personally any day. I find the flow is better. My deposit's better. I'm actually getting a better horizontal stack as opposed to having to stack it vertically. So I'm able to help cover the fibers of the shirt and lay down a smoother print without having to do maybe a flash print of that white just to get those same things matted down. So it's really important to play with that as another variable. Now, it's not going to say like, hey, if these are better, why don't we use them? Well, because they're not necessarily better. It's how are you using it? And the downside of a thinner thread is they're going to pop easier, right? Because you've got a thinner thread. It's going to be a lot more unstable and not be able to handle getting beat up as frequently as most screens usually are. But it's a great question. I definitely recommend that if you've got a supplier nearby that has any kind of thin thread mesh, get a few. They're going to be a little more expensive, but test them out. You might see a pretty good difference. You might decide you want to switch meshes, certain meshes, to a thinner thread, or figure out what kind of printing do I prefer that to be. I really love, like I said, the 130 over a 110 almost every time. And I really enjoy using it for water base. That open area, once again, really helps that water flow, and it prevents a little bit more of that cling and dry that we talked about. I don't know if you agree with me on that, Mike. I mean, you don't have to. It'd be wrong, but you don't have to. I'm kidding.
No, I always agree with you, Matt. No, I really do. I on most of it. I mean, for Discharge, when I was in the screen room, we did use thin thread mesh, and we used it because we printed a lot of discharge underbases, like very few plastisol underbase. So the thin thread allowed for that larger open area and allowed for a better deposit of all that discharge to get that vibrancy. Just remember that, if you're using a thinner thread, if you have a 230-48, 230-40, that 48 is going to have a little more real estate to that. Thread's going to be a little thicker. You're going to have a little more surface area for emulsion to cling onto. So if you have a thinner thread, you run the risk of possible breakdowns, and you may not hold some of those shadow dots, those small dots that need a thread to hold on to. It might not be there.
Yeah, that's a good point too. You can see that you can't really make one overall answer, right? If it was that easy, we'd only have 6 or 7 different mesh types, period, and all the manufacturers would match these. There's so many unique different variables and reasons why you want it to be unique and you want it to be your way. So don't ever listen to anybody, me included, telling you that one way is the best way. There's so many ways to do this. And like Mike started off with, if it's working for you, it's the right way. But it's definitely important to understand these variables. I was at M&R earlier today for some other things. I was talking with a guy that runs a phenomenal shop up in the Rockford area. And I was kind of just shooting it with him, and we were talking. I was like, honestly, what do you think the percentage of people that run shops or own shops or should be in the know, what do you think, how many do you think they actually know all these variables? And his answer was that he thought no more than 55% of shop owners actually really understand these variables. And that's a big thing to think about, right? If you're doing screen printing, Richard Greaves is great. Screen printing, right? The word screen is the first part of that. So I can't emphasize enough how important it really is to understand. Now, if you're the owner, you might not need to understand this, right? Your job is to understand who to hire to understand these things, right? But you need to have somebody in your shop that's holding these things and taking accountability for them, gathering these data points and understanding, okay, what is a thread diameter difference? Does that matter? Another great question to know the answer to is one that Cole has brought up is certain lights, is it important? If you have LED, metal halide, do those things matter? Understanding these different variables is really important to help understand how to move forward in your screen making game. So with that question that Cole asked, Mike, do lights matter? What are the different kinds of lights that come with exposure units usually, and what are the differences that you see with those?
Yeah, I mean, they absolutely matter. And, we touched on it briefly. There's so many variables. There are so many things that go into creating, the perfect screen. And the light source that you're using is definitely one of them. My go-to is the metal halide, a single point light. So you have your mesh, your screen, you have one light hitting it. Some of the LEDs and other light units of fluorescence and things will have multiple light sources. And when I say light sources, I mean multiple bulbs. So you have numerous rows of LEDs or numerous fluorescent tubes. That light is going to scatter. It's just going to be coming at the screen at all these different angles. And you run the risk of undercutting. You lose resolution because of that. Not only are the lights going to affect that, the types of lights, The distance is going to affect, so that requires energy. So the farther your light is, the longer your exposure time is going to be. The closer it is, the shorter. But then that also creates issues, whether or not you're using a single point or multi-point. It's a rabbit hole that we can go down forever. But yeah, I mean, I don't know. I mean, I don't know what else to add. What do you?
No, absolutely. Now, I think it's important to note this, that once again, if your screens are working for you, no one's saying you're doing it wrong. It's just important to understand these variables, right? So each type of bulb is going to be different, right? So traditional bulbs have gases in them. Those gases are then ignited with the power source and they glow. Now that glow is going to have different wavelengths of light, and that wavelength of light is going to impact the emulsion, and it's actually going to go through the different layers of emulsion differently until it hardens or cures, or cross-links, right, is the word, to solidify that into a good solid. Now, I spent a good 4 or 5 years of my early screen printing days in my teens using the sun as an exposure unit. Now, it couldn't hold the fine detail that Mike can hold on a metal halide, right? But it worked. So it depends on what you're trying to do. If you are trying to get into printing on 305s or high mesh and do sim process, and you've got a home built unit with like 10 different just random bulbs ballast down it, you might have a very hard time. It doesn't mean you can't do it, but you're not going to have the same effect as somebody with a single source metal halide that's banding out and providing one source of light that's concentrated and the correct full gamut of wavelength. So that will impact your print. LEDs are very, very popular, especially in the last couple of years. They're great. They're going to be able to take an exposure unit down to being incredibly fast, right? I've seen a lot of them 18-second exposure times. Now, for me, I never really cared too much about that because my process wasn't stacking up 20 screens and then knocking those out. Now, I've got friends at shops that's what they do. They'll do like 20 screens, and then they'll stand there and every 13 seconds taking a screen out, and that works for them. Now, if they're also not trying to get into award-winning sim process either. They can do some sim process, but they're not trying to go win awards with the best resolution, looking under a loop and analyzing that. But absolutely, the type of exposure you have, the type of light source you have, not only that, what is your bulb like? Now, LEDs, the bulbs are going to be good forever. But if you're dealing with a metal halide, a fresh bulb versus a bulb 6 months later, 8 months later, very different, right? So it's really important to understand that is also a huge variable that you need to understand, respect as a variable, and then be able to control it and test it as you go along too. So yeah, great question about the types of light. They're all going to do their job. Like I said, the light, the sun itself will do it too. And that actually brings up a good point too that I want to also talk about is post exposure, right? That's a big one that we hear a lot of. I've always been a big fan of shops if it's in the summer or like my little manual shop that I've got. After I expose my screens and rinse them, I'll just go put them out in the sunlight and let them dry out there. And I face it to the sun, squeegee side up. That way I'm hitting the light the other side and it's helping dry it. But Mike, what would you say to shops that are curious about post exposure? Is it beneficial? Should they do it? And what effect does it actually have on the screen?
Yeah, I mean, it's not going to hurt anything, that's for sure. If you're having issues with breakdown, especially if you're running water-based or discharge, and you're using like a single cure SPQ or a dual cure SPQ, you can always post expose. So basically, you're going to expose your image. You're going to develop it. Once it's dry, you just set it back, like Matt said, right back onto the exposure unit with the squeegee side facing the light source. And that's just going to basically kind of continue the reaction as much as you can. But just remember, if you underexpose too much and you try to post-expose, it's probably not going to help, because if you underexpose, that emulsion that hasn't reacted to the UV is just going to wash away during development anyway. So you're basically you're just post-exposing already exposed emulsion, already cured emulsion. So it does help, and it could prolong the life on press for sure. But again, that's just for it works with water-based and discharge.
Would you recommend like a rule of thumb, just if you can, post expose all the time?
Yeah, it's not going to hurt. It's not going to hurt anything. It's only going to help. So I would say I would agree with you on that. Yeah.
Awesome.
Great. We're going a little bit over time. I have a real practical last question here. How do we put this to action? We talked about so much great information. I'm sure some of the people watching it are going to watch it again. But how do we put this into action? What do we do? What are some practical first steps to start implementing this information in your shop?
I mean, I would say that you want to buy some of those things we talked about, right? I mean, the hygrometer, the exposure calculator.
Two hygrometers, one for the dark or one for the screen room, one for the shop floor. The exposure calculator. That sounds like that's how you can actually take some trackable data. And how do you have to buy one every year, something like that, or what's the deal with those?
What, the calculator?
Mm-hmm.
It's kind of a one and done deal. I mean, as long as you keep it healthy, you don't drop it in the dip tank, you're okay. Yeah, you get one, and it should last for as long as you keep it. Good.
It's not like a process film. Some folks up there might be like, oh, well, when I get my film wet, it's ruined. It's not at all like the film coming out of your inkjet. This is actually a processed image set film. So it can get wet and just dry it off. It's fine. So, I mean, I've got the same exact one, the Kiwo one that I've had for a decade now. I mean, the folder is a little beat up, but I've been keeping those films healthy. I mean, and they've gotten stuck. I've had screens that it got stuck to it. I had to like sit there and peel it off and then like take my fingernail and scrape the ink off or something, the emulsion off. But yeah, it should last you your career. I mean, they're not the cheapest things. I think I don't want to price it completely, but I want to say somewhere around the $75 range, roughly. Depends where you're buying them from. But it's going to last your career. So as a shop, you should have one for the shop. And like I said, $75 range to have for the shop indefinitely to test these things. Like Mike said, at least 4 times a year, you should test every single screen. Because you also have to check, okay, from January to March, maybe you're in a place in the country or in the world that doesn't really have that big of a swing when it comes to temperature or humidity, but your bulb's been used, right? So if that bulb's been used for 8 months, maybe it's degraded a little bit. You need to actually adjust and put it on longer to make up for that bulb slowly dying off. Or you've got a brand new bulb and you the exposure calculation last time on a year-old bulb, that brand new bulb's going to be coming in hot, right? So you want to make sure that you're accounting for that too. So yeah, I mean, the hygrometer, like I said, you can get that off of like Amazon for like $10. You can look that up. Hygrometer, oftentimes it's called a hydrometer, but it's actually called a hygrometer with a G in there. But yeah, get one of those, $10, get 2 of them, put one by your press, one in your dark room, get an exposure calculator, or just get a vector and repeat that vector 10 times. And then you can just get a piece of cardboard, something that's going to block like tin foil, right? Blocks light really well. And you can set it on there, expose it, move it over, expose it, move it over. And you can make your own without having to buy one, right? It's just have the same image. And as it keeps going, you're going to keep exposing the first one over and over and over again. And you're going to end up having 10 different exposures all on one screen. And that's going to give you a better idea of what you're looking for. I always am a fan of just buy the calculator. It's made for this. But if you don't have that available or you're not quite sure if you want that, still find your own way by doing it like that to test out what those different times look like.
And then one more, and this one's free, or maybe you pay $5 for a whiteboard. Keep your data. Start tracking your data. You don't got to buy anything for that. Put a piece of paper on the wall, and you can go back in the video and look exactly. Just do it like Mike does. If you're keeping your data, that's going to up your game fast. You know, from 0 data to some data, you're going to really notice changes. That's really going to help. So those 3 things, the hygrometer, the calculator, and keeping your data, that's where we recommend you start. And we'd love to hear about how it goes. You know, we're going to do another one of these in 2 weeks. And come on back. Tell us how it's going. Keep asking questions.
The last thing I want to say too, keep an open mind. The worst thing that you can do is think that you know the answer. This is an ever evolving industry and your screens are going to ever evolve. So many variables are changing. Don't ever say, well, that can't be because. Find out why it can't be and find out if maybe it could be, right? Be open to test. Be open to getting new insight and new data points. Don't decide that you are the end all on your data points. They're going to change. Be open to evolving with them and track the data, but never decide it's a permanent, because it's going to always be moving. So don't think you know everything. Keep learning, keep asking questions, keep making mistakes, keep breaking screens, keep breaking down on press, keep doing all these things till you find the perfect screen for you.
That's perfect. That seems like a great note to end it on. But Mike, any other thoughts? Anything else you'd like to share with the crowd?
No, it's a pleasure. Thanks for having me. I agree with you guys. I agree with Matt. You don't know you're doing something right until you have done it wrong, right? I mean, made a lot of mistakes at screen making, and you just track what doesn't work, and you can find the path for you. So
there we go. Well, thanks so much, gentlemen, and thank you, everybody watching. We will be back in 2 weeks, and we will put up what we're talking about soon. If you want to watch this again, it's going to be on YouTube, but you can also watch it on this link right when it's over. So thank you again so much for Mike for joining us, and Matt, as always. Everybody else, have a great rest of your day. Thank you, fellas.